In this video, we'll look at limits. And with a limit, we look at what happens for a graph as our input approaches a value, but does not actually equal that value. The notation that we'll use, and make sure that you are familiar with this, is what you see on your screen right now. We say this as the limit of f of x as x approaches a equals L. This means as x approaches some value a, but does not equal it, then the output of our function will approach a value L, and L is considered the limit. Let's look at an example. Alright, in our graph, we should be familiar with this from all the rational functions we've been graphing. We notice that the limit as x approaches negative infinity. So as we move really far to the left, the limit of our function is negative 6 because my outputs are going to negative 6. Let's now look at this vertical asymptote. We see that the limit as x approaches negative 4 is negative infinity because as I go from the left and the right, my outputs are both going down to negative infinity. We can look at the other vertical asymptote. The limit as x approaches 2, so as we go towards 2, my outputs are both shooting up to positive infinity on either side. So in general, my limit as x goes to 2 for the function is positive infinity. And lastly, my limit as x goes to positive infinity, so as we go really far to the right, the output goes to negative 6. An interesting thing to note is that you can also look at limits around a particular point. For example, the limit as x goes to 3 is simply 0. And that's because we have a point at 3, 0, and we do approach that point from either side. A little later in the videos, we'll look at an example where that doesn't happen. Hopefully this right now made sense to you, because we're going to go on to one-sided limits. With one-sided limits, we look at what happens as our input approaches a value from only one side. We have special notation for these. For a left-sided limit, we have the limit of f of x as x approaches a from the left. So we put a little negative after the a to indicate we're coming from the left. For right-sided limits, we have the limit of f of x as x approaches a from the right, which we indicate with a positive after the a. Let's go back up to our graph. We see that at our vertical asymptote, we can look in particular at the left and the right. As we approach the vertical asymptote from the left, so the limit as x approaches negative 4 from the left is still negative infinity. As we approach from the right, the limit as x approaches negative 4 from the right is also negative infinity. If you were to get something a little bit different, for example, if we had a graph that looks like this. Here's our Cartesian plane, and we're going to put a vertical asymptote at negative 3, but we're going to go down on one side and up on the other. Well, we see that from the left, the limit as x approaches negative 3 from the left is negative infinity. So as we trace our graph on the left-hand side, our outputs are going down to negative infinity. We can also look at what happens as, nope, I want this in green. The limit as x approaches negative 3 from the right. And in this case, we see that we go up to positive infinity. Well, since from the left we're going to negative infinity, the right we're going to positive infinity,